In this tutorial, you will learn how to turn on and turn off an LED with a push button using your Arduino board. So first of all, we are going to create the circuit with the LED and the push button. Then we are going to write a first code so that you can power on the LED when the push button is pressed. And after that, we are going to improve the code so that you can toggle the LED when you press and release on the push button. And let's get started with the circuit. So I'm first going to use here a simulation with Tinkercad so it's easier to explain the circuit, and then I'm going to show you, of course, the real circuit. We will need an Arduino board. Okay, so just take your Arduino. I have an Arduino Uno, but it doesn't really matter. A breadboard. All right. And then we are going to do the LED. So let's take an LED and let's plug it right here in the middle. So any color you want. Okay, I'm gonna use green just for this example. What you're gonna do is to connect. So you have two legs, okay, the cathode and the anode. So the cathode is the shorter leg, okay. You're gonna connect the shorter leg of the LED to the ground. And to connect to the ground, we are going to use this minus line here on the breadboard. So I'm just gonna add a wire here, put it in black color, okay, convention for the ground. And then, so let's use this connector here. So you have different grounds, so any ground will do. I'm just gonna use that one. Okay, just connect the ground here like that. Okay, so the ground of the Arduino is connected to this line on the breadboard, and now it's connected to the shorter leg of the LED. I'm gonna add a resistor. So resistor here, and we're gonna choose a 220 ohm resistor, which should be, so I'm gonna turn it, I'm gonna make it rotate, should be red, red, and brown if you have a 4-band resistor, and if you have a 5-band resistor, should be red, red, and then black and black. I'm gonna connect this here, so to the longer leg of the LED, and then on the other side of the resistor, I'm gonna add a wire to digital pin number 8, for example. Okay, so digital pin, so you can control, let's put green, so you can control the LED with this pin. Okay, so now the LED is done. Let's add a push button, so just search for button, and let's add a push button here. You can add it in the middle of the breadboard like that, okay? And first of all, we are gonna connect another resistor, so just check for resistor. And let's connect this resistor between one leg here on the left, for example, of the button, and then the ground. And we're gonna choose 10 kilo ohm. So 10 kilo ohm would be brown, black, and orange. And if you have a 5-band resistor, that's gonna be brown, black, and then black again, and then red. Okay, and then the tolerance. Okay. So this will act as a pull down resistor. So then when we read the button state, we're gonna read low, so 0 volt when the button is not pressed, and 5 volt when the button is pressed. All right. So with this, we set the default state. Then from the other side, so on the left, you have the ground, for example. Then on the right, you're gonna add a wire connected to 5 volt here. Okay, so I'm just gonna make it, for example, I'm gonna plug it here, and then put it red, and then connect this red here to 5 volt here. Okay, so it's the same thing. You could just use one wire, or just connect this to this plus line and connect the plus line to 5 volt. Okay, so now we have this, and then what we need to do is to connect, of course, a digital pin so that we can read from the push button. So we're gonna go from the same side here on the left side. So from the same side as the resistor, which is connected to the ground. That's very important. So either here or here. Let's connect it here, for example. And let's add a wire to, so let's put it there, for example, to digital pin number 7. And well, just orange or any color you want. All right, and the circuit is complete. Let's now check the real circuit. And here is the real circuit. So first, of course, make sure that you have unplugged. So the Arduino is not powered on. Okay, that's very important. And then you can see, so on the Arduino, we have a black wire here to connect the ground of the Arduino to the black line, okay? And then for the LED, so we have the LED here with the shorter leg connected to the ground and the longer leg connected to another line of the breadboard. And we have the 220 ohm resistor. And finally, this green wire between the resistor and digital pin number 8. Okay, so the circuit is closed. Then for the push button, we have, so push button is here in the middle. We have a 10 kilo ohm resistor, which will act as a pull down resistor, okay, between the left side here of the button and the ground line, which is already connected to the Arduino. On the other side, so on the right side, I have a red wire connected to 5 volt. Okay, so that's very important. Here, ground with the resistor and then 5 volt. And then here I have a orange wire from the left side of the button to digital pin number 7, and the circuit is complete. Now you can power on the Arduino, so I'm just gonna plug it to my computer. And let's write the code. The first application we're gonna do here is to turn on the LED when the button is pressed and simply turn it off when the button is not pressed. So that's the simplest thing you can do, I think, okay? Let's start with that. So first of all, we are gonna create some defines here. Define LED pin, so all uppercase, okay, with the number of the pin. So LED is on pin number 8. And then define button pin on pin number 7. This is very practical, this is very useful, so that anytime we use the LED pin, we just use this define, okay? So if in the future, let's say you use LED pin with pin number 9, you just need to modify here at the top of the program and everything else will be updated accordingly. Okay, now the setup. What do we need to do in the setup? We need to set the mode for the pin. Is the pin an input or an output pin? Okay, so with pin mode like that, LED pin, so we use the define we have created here, and the LED pin will be output. Output because we want to control the LED. And then pin mode, button pin, which is going to be input because we don't want to control the button, we want to read data from the button, okay? And well, we already have, with the button, we already have a pull down resistor, okay? So the 10 kilo ohm resistor will make sure that when we read from the push button, we're gonna get 0 volt by default and 5 volt when the button is pressed. So that's it for the setup, okay? Nothing more to do. Let's write the code for the void loop. So what do we want to do? It's very simple. We want to simply turn on the LED, so power on the LED when the button is pressed. So let's put that into code if. So how do we know the button is pressed? Well, we have the function digital read with button pin, which is gonna give us high or low. Okay, those are two also defines in Arduino. So we can check with two equal sign. For example, high, you can see it turns blue. I can also check low, okay? So let's check high. So basically, if what we read from the push button is high, which means close to 5 volt, then we know that the push button has been pressed with our setup. And in that case, what we want to do if the button is pressed, we want to turn on the LED. And to turn on the LED, we use digital write. Okay, so digital read to read and digital write to write. That's quite straightforward. We use the LED pin with high also. Okay, so when you put high, it's gonna turn on the LED. When you put low, it's gonna turn off the LED. So we have the first case, when the push button is pressed, we turn on the LED. But then when the push button is not pressed, we also want to turn off the LED. So in that case, I'm simply adding else here. I'm not gonna do else if. I could do else if and read the push button again and check if it's low, but here there are only two possibilities. Either it's high or it's low. So if it's not high, then it's, of course, it's low. So I can just put an else right here. And I'm gonna do digital write LED pin with low. And the program is finished. So that's very simple, just 16 lines of code. And here, well, the thing is that the void loop is gonna repeat indefinitely. very, very fast. Here we don't have any delay, we don't have anything waiting. So it's always gonna check the push button and simply power on or power off the LED depending on the button state. And let's actually run this on the Arduino. So let's try the code to see if it's correctly working. So tools, make sure you have the correct board checked here, and then port, you have the correct port. So here I have my Arduino Uno board. I'm gonna just upload the code and I'm gonna name it, let's say LED push button. Okay, let's save it, and so it's gonna compile and upload. Okay, and once you see down uploading, the code is in the Arduino Uno, and now so you see the LED is powered off because the push button is not pressed. If I press on the button and I keep pressed, the LED is turned on. I release, LED is turned off. Okay, I press again, on, off, on, off. All right, so it's correctly working. Great, so we have finished this first program, and now let's improve it. So what do we want to do next? We want to toggle the LED state with the push button. So when the push button is actually pressed and released, we're gonna toggle the LED. So the LED is gonna be powered off, and then we press and release, the LED is gonna be turned on, and the next time we press and release, the LED is gonna be turned off again, etc., etc. So that's just a little bit more complex, but still we are gonna manage to do it in just a few lines of code. So what do we need in the code? Well, first we need to define the pins, that's the same thing. Then we need to set up the pins, exact same thing. And then in the void loop, we're gonna write a different application. So I'm just gonna remove all the code, and let's start again from the void loop. So the question is, how do we know we have pressed and released the button? So basically, we just care about the release state. Okay, so the release is between the state high and the state low. So now the question is, how do we know that we have released the push button? Well, to know that, we will need to compare the current state of the button with the previous state. So we will need to keep track of the push button state, okay? And so I'm gonna add a variable here, a global variable, byte, so that's a byte data type, last button state. And I'm not gonna initialize it here, I'm gonna initialize it right there in the setup. Let's say last button state is equal to digital read button P. Okay, so we start with a last button state, which, okay, this is the current one, but now that's gonna be the last one when we start to get the current one once again. So in the void loop, the first thing we do is to do byte button state. So the current one is equal to digital read button P. So we read the button again, and now we are gonna compare the current button state, which is named button state, to the last button state. So we're gonna check if it is different, not equal, but different. Last button state. And so if the current button state is different, we know that something has changed. So we have two cases here. Either we have pressed on the push button, in this case the previous state was low and the current is high, or we have released the push button, which means that the previous state was high and the current state is low. So now that we know that something has changed, we just need to check. So if button state is equal to low, we know that the button has been released. If you want to check if the button has been pressed, you just do if button state is equal to high. Okay, and the combination of this information, which means that the button state has changed, and this information, which is the current one, gives you either the information that the button has been pressed or released. All right. And one thing I'm going to add also here, just after we have detected that the state has changed, I'm going to also update the last button state to the current state. Why is that? Because, well, once the state has changed, the next time you're going to enter the loop, well, the last button state must be different. All right. If it was high before and then it's low, well, you need to update the last button state to say it was low. So then you can compare again and again. If you don't update this, it's gonna work the first time, but then it's not gonna work anymore. So then, what do we do in this if? Well, here we know that the button has been released. So we are simply going to toggle the LED. And to toggle the LED, well, we have kind of the same problem here, is that what was the previous state of the LED? Because if it was low, we're gonna put high. If it was high, we're gonna put low. So I'm gonna add also here byte LED state and just initialize it to low, okay, which means that the LED is powered off. And then in the setup, well, we don't need to power it off because it's already powered off. Okay, so we could add digital write with LED pin and low, but that's not useful because that's already the case. And so what we're gonna do here first is we're gonna do if LED state is equal to high, and then we put LED state to low, and then else LED state is equal to high. So we just toggle the LED state. If it's high, we set it to low. If it's low, we set it to high. And then we can do digital write LED pin with the new LED state. And the code is complete. So to recap here, first we read the button state. We check if the button state is different from the last one we have read, okay, which is a global variable. If it is different, then first thing we store the last button state, okay, we make sure that the current one is the last one for the next loop. And then we have the information that the state has changed, so we have only two cases, whether it's priced or not priced. So we check the button state again, but we don't read it again, we just check the variable. And then if it's low, we know that it has been, so I'm just gonna put a comment here, released. And if it's released, then we can do whatever we want. And here what we want to do is to toggle the LED. So we toggle first the LED state, okay, we change the state, and then we use it with digital write. And it's gonna repeat again and again and again. Now I'm not gonna run this program right now. Why is that? Because, well, with this code, we might have a slight issue with the push button, and this is the bounce of the push button. So basically what's gonna happen with the push button is that when you press or when you release on the push button, well, the state is gonna change, for example, from low to high or from high to low. But in reality, the button can physically bounce on your circuit, okay? That's not something you can control in the code, that's in the circuit, that's physical. So bounce means that the button state may change a few times very quickly when you actually press or release. So for example, if you press, the state should be from low to high, but maybe what's gonna happen is gonna do low, high, low, high, low, high very quickly, and it's gonna end with high, but you're gonna have all those changes of states very quickly in a short period of time, and this is the bounce. And this will happen in just a few milliseconds. And the thing is, if you run this program like that, it's gonna be annoying because when you press on the button, sometimes it's gonna detect that the button has been pressed or released 3 times in just a few milliseconds, and that's gonna just make your application not work correctly. So what we're gonna do is we're gonna add a debounce mechanism in the code, and this debounce mechanism is actually very simple. What we're gonna do is to say that when the state has changed, so here when we detect this, we are simply gonna ignore the following change of states in the next few milliseconds. So for example, the next 50 milliseconds. So if we ignore that, then the next time we read the push button, we know that all the physical bounces have passed, and so we can have reliable data. And to do this, I'm gonna add another 2 global variable here, unsigned long. So we're gonna keep track of the time here. Unsigned long last time button state changed is equal to, well, let's say millis or 0 for the beginning of the program, it doesn't really matter. So we're gonna keep track of the last time the button state has changed so that we can ignore the following, let's say unsigned long debounce duration is equal to 50. That's gonna be millis also. So that we're gonna ignore the following 50 milliseconds. We're gonna ignore the button for the following 50 milliseconds. Now that we have those 2 variables here, let's use them in the void loop. And so first of all, after we have checked that the state has changed, we are gonna do last time button state changed is equal to millis, and millis is the current time in milliseconds. So now with this, every time the button state changes, we know when it was exactly. And because of that, I'm going to add another if here. If millis minus last time button state changed is greater or equal than debounce duration, we are going to execute this block of code here. So I'm just gonna remove these curly brackets like that, and just put a curly bracket here at the end, and everything I'm gonna select and press tab to add one indentation. So now everything is in the if. Okay, so we have the void loop and then the if, and everything is in the if. So what do? We simply do, well, the time now minus the last time the button state has changed, which means that we're gonna get a duration. What is the duration since the last time the button state has changed? If this duration is greater than the debounce delay, so 50 milliseconds, then we can read the push button. If not, we don't read the push button. So this is gonna continuously read the push button until we detect a change of state. If we detect a change of state, we update this with millis, which means that the next time we enter the void loop, we're gonna check the time again, and if 50 milliseconds have not passed, then we don't enter the if again. And this will make sure that when the state changes, we ignore everything after for here 50 milliseconds. Okay, so I use 50, this is a pretty common value. It works great for me, but you can of course increase it or decrease it and see what's gonna happen. So maybe increase it if you still have bounces, or decrease it if you want a faster update until you see some bounces, and then you try to get a good balance so you don't get bounces. All right, now let's run this code. So let's upload that to the Arduino. Uploading, down uploading. And now let's actually press end. So I'm pressed, nothing happens. I release, you see the LED is turned on. Now I press again and I release, the LED is turned off. Okay, I need to press and release to change the state of the LED. Press and release. And you can see I don't have bounces. So bounces would mean that you would see the LED blinking very, very fast. For example, if I do this, the LED could blink a few times and this is a bounce. So if you have that, go back to the code and increase the debounce duration. Okay, but now it's working just fine. All right, and now you know how to work with an LED and a push button together. And this may seem like a very simple application, but actually with all of that, you have covered a lot of basic things with Arduino, and those basics will be helpful for you for any project you do in the future. If you liked this video, subscribe to get more tutorials like this in the future. Also, check out my online courses so you can learn Arduino step by step in an efficient way by practicing and directly going to the point. Links in the description. Alright, thank you for watching. See you in the next tutorial or in one of my courses.